All right, guys, today's warm-up has 4 questions, and so let's get started. First, it says, what is STP? STP stands for Standard Temperature and Pressure. Okay. So for number 1, all right, our standard temperature is going to be 273 Kelvin, which is 0 degrees Celsius. And our standard pressure is going to be 760 millimeters of mercury, which is equal to 1 atmosphere. All right, so that is standard temperature and pressure. Number 2, if we took 15 liters of gas at 1.25 atm and compressed it to a pressure of 4.56 times 10 to the 7th millimeters of mercury, what would the volume in liters of that gas be at the new pressure? All right, so for this one, let's just go ahead and list the things that we have. All right, we have a volume here and a pressure here. And it says that we're going to compress this volume of gas to at this pressure, and we're going to compress it to this pressure here. And we want to know the volume. So it appears that we have a P1 value, a V1 value, and a P2 value. And we want to find this. All right, so my P1 is 1.25 atmospheres. Volume is 15.00 liters. And my second pressure is 4.56 times 10 to the 7th millimeters of mercury. All right. Now, it's important to note here that I have atmospheres here and millimeters of mercury here. So I have to convert either the atmospheres to millimeters of mercury or millimeters of mercury to atmospheres. It doesn't matter which one you choose. Me personally, I like to work with atmospheres. So I'm going to go ahead and convert this using my conversion factor because I know that 760 millimeters of mercury is equal to 1 atm. And so when I work this out, I should get 6.00 times 10 to the 4th atms. All right, so it appears here that I'm going to be using Boyle's law, okay, because I have pressure and volume, I'm going to go ahead and assume that I'm keeping this at a constant temperature, which is what we're going to do over this unit as we're given these problems. So as we do this, I know that Boyle's law is P1V1 is equal to P2V2. All right, so let me just double check now. I have ATMs, I have liters, so that means my answer will be also in liters. So let's go ahead and set this up. 1.25 P1 times V1 is equal to P2 V2. All right, so this gives me 18.75 is equal to 6.00 times 10 to the 4th V2. Divide both sides. And that should give me a V2 of 3.13 times 10 to the negative 4th liters. All right, number 3 says, what volume will 4,657 milliliters of a gas at 8.0 degrees Celsius occupy at STP? All right, so let's go ahead and see what we have. We have a volume and we have a temperature. So this is going to be a V1 and a T1. And I also have STP. All right, for number 3, it says, what volume will 4,657 milliliters of a gas at 8 degrees Celsius occupy at standard temperature and pressure? All right, So for this one, we have to consider that the only thing that's going to change here is our temperature. All right, we're going to assume the same constant pressure here. So if we are now here at a V1 and a T1, okay, then maintaining that standard pressure, but now we're going to make it also a standard temperature. And I know that my standard temperature is going to be 273 Kelvin. So what's going to help us with this one? Well, we're going to use Charles's law. Charles's law says V1 over T1 is equal to V2 over T2. So let's just go ahead and revisit what all of my variables are. V1 is 4,657 milliliters. T1 is equal to 8 degrees Celsius, which is equal to 281 Kelvin. I don't know V2, that's what I'm solving for. But I do know T2 is equal to 273. So I can go ahead and plug these values in. 4,657 over 281 is equal to V2, which I don't know what it is, over 273. So to solve this, I cross multiply and divide. So I'm going to multiply these two. And then I'm going to divide by 281 for an X value of 4,500 milliliters. I know that my unit is in milliliters because I started with milliliters and I did not convert that. Okay, so my answer will be in milliliters. All right, that's number 3. All right, for number 4. Number 4 reads, how many moles of chlorine gas are there in 22.4 liters of chlorine gas at STP? All right, so here we're dealing with moles, and I know that there's only one equation that deals with this, and that's the ideal gas law. And the ideal gas law says PV is equal to nRT. Okay. So that's the ideal gas law there. Now, one thing to keep in mind about the ideal gas law is that we're going to use R as a constant. Okay, I know that R is going to equal 0.0821 and that it has a very specific unit of measurement. And that unit of measurement is liters times atmospheres over mole Kelvin. So I know that everything that I work with in this equation, my volume has to be in liters, my pressure has to be in atmospheres, I have to use the mole, and my temperature has to be in Kelvin for this to work. All right. Now I am given standard temperature and pressure. So I know that my temperature is 273 Kelvin. I know that my pressure is 1 atm. Okay. I'm also given my volume in liters. And all I'm solving for here is moles. Now I already have R. I have my temperature, pressure, and volume, so all I have to solve is for N, or for moles. So I'm just going to go ahead and plug these into my equation. So my pressure times my volume is equal to N times my gas constant here, and my temperature, 273. So I'm just going to start working this out through this algebraic equation. And I get an N value of 0.999 moles. Now, if you're like me, you're like, wow, that's really close to N is equal to 1. Okay, so it's about 1 mole in 22.4 liters of gas at STP. Kind of keep this in the back of your mind. We're going to revisit this later on, but I did kind of want to give you just some practice with this ideal gas law. All right, guys, so that was our warm-up for today. I hope you guys have a great day. If you have any questions, please let me know. As always, make good choices.